Welcome, and thank you for joining us today at Climate Central's monthly climate briefing. Climate Central is a non-profit, non-advocacy organization of scientists and communicators. Our team researches, reports, and creates resources for storytelling that can be used for anyone interested in communicating science and the impacts of climate change. This is a good place to remind you that these resources are free and available on our website, and we encourage you to use them. That's what they're there for. Our content is straightforward and visually compelling, hopefully you agree, and includes data to make the link between weather events and human-caused climate change. This month's briefing, we will cover the weather from April 2026, correct? As well as year-to-date summaries. And for all those who are going to be anxious and waiting, Zach will talk about ENSO. So just hold on for that. Our special guest this month is Dr. Ali Mazowick of Colorado Climate Center, and Zach will tell you more about her after he speaks. So, to Zach, leading our discussion is Dr. Zach Labe. Zach's interests explore the intersection of climate impacts, future scenarios, extreme events, early warning predictions, and applying novel data science methods. In addition to these research areas, he is very passionate about improving science communication and data-driven visualizations. Zach is a well-regarded data communicator on his own. If you have seen his own personal social media accounts. Zach was a scientist at NOAA's GFDL before joining Climate Central last spring. So, Zach, tell us the story of the climate.
All right. Thanks for the introduction, Jen. And hi, thanks everyone for joining today. We're really excited to dive in. There's a lot going on as usual. And so we'll just start off. Quick reminder that in addition to these webinars, which also are recorded and shared after the event, we also prepare these monthly sort of state of the climate reports that are available on our website for each month. So if you miss any of the data, statistics, or want to download some of those graphics, we encourage you to go to our monthly climate brief website where you can find all of that content there, as well as the webinar recording. In addition, we also have a new set of interactive graphics where you can monitor changes in global temperature, changes in greenhouse gases, and interact with the data yourself. And that's all, again, available on that website. So for today, what we're going to be talking about is a sort of roundup of global climate, checking on the latest indicators, and then we'll dive into really what's been a remarkable year across the United States for just persistent warmth and dry conditions. So we'll check in on where we are year to date as well as April. And then, as Jen said, we'll have a special guest today talking more about what's been going on, particularly across the West, for snow and water and current climate conditions. And so we'll start off, as usual, with our climate moment of the month. So this month, I wanted to focus on ocean temperatures because if you've been monitoring and hearing any of the headlines, it has been warm. So what this graph is showing, it's showing daily sea surface temperatures for the entire globe. And so the yellow line is showing for where we are this year. The really thin gray lines, those are showing other years. In fact, all years since 1982. And then if you notice, there's a sort of faint blue line, and that's sort of the climatological average. So as you can see, where we are in 2026 is way above average. In fact, we're at the very top of the graph for the data that pulled up. As of yesterday, we are at record high global sea surface temperatures. And to me, this is really a striking statistic given that the El Nino really hasn't fully developed yet, and we're already seeing remarkable warmth around our global oceans. In fact, in particular, ocean temperatures have been really warm across the southern hemisphere, where they were the warmest April on record for that particular region. So this graph you can also interact with, and we recommend checking out this latest data as the year progresses. So what about checking in on some of the drivers of this warmth, like global climate change? Well, we are approaching the seasonal peak of carbon dioxide levels. So this graph is showing weekly levels of carbon dioxide. So the bottom is showing for the months, and the y-axis is showing the amount of carbon dioxide for some of the recent years in particular. So you can see those red lines are increasing over time. That's the long-term increasing amount of carbon dioxide due to the burning of fossil fuels from the human emission of greenhouse gases. But in addition, there's this seasonality to carbon dioxide, where typically we observe a maximum in the amount of carbon dioxide right around this time of year in May. And this is due to all of the vegetation that is starting to grow across the northern hemisphere that helps to suck up some of that CO2 in the atmosphere, which reduce levels ever so slightly during sort of the summer months of the northern hemisphere. So it's responsible for this seasonality. So carbon dioxide levels, in fact, for April for last month, set a new record high for the highest recorded month on record from the Mauna Loa Observatory. And we'll check in next month for May, which is typically that seasonal peak, to see how high carbon dioxide levels got this year. In addition to carbon dioxide, we know that there are other greenhouse gases that are important drivers for our warming planet. Two of the other large contributors are methane and nitrous oxide. So methane is on the left, showing the graph of conditions, the amount of methane in our atmosphere since the 1980s. So you can see there's some variability and increase in particular over time. And on the right-hand side, we can see nitrous oxide, which is also increasing over time. Both 2026 are at or near record high levels for these greenhouse gases. And so now let's dive in to check out what were conditions around the world for last month in April. So this graphic is showing again those temperature anomalies. What that means in climate science terms is anywhere the red shading is warmer than normal conditions, anywhere in blue is colder than normal conditions. So we can see, as usual, there's always a lot of spatial variability across our planet, meaning that the temperature anomalies from region to region differ. And that's due to things like weather patterns and other climate oscillations that influence. But overall, if we average across the entire planet, April 2026 was the fourth warmest on record using NOAA data in particular. We can see pretty striking anomalies across the polar regions. So those really deep reds across Antarctica and the Arctic last year, indicating that temperature anomalies were well above 5 degrees warmer than normal. We can also see in North America a really sharp contrast between colder than normal conditions across parts of northern Canada, but very warm, particularly across the eastern half of the United States. Again, as I noted earlier, oceans have been particularly warm. So if we take a look at the average over ocean areas for temperatures, they were the second warmest on record for the month of April, in particular across the southern hemisphere. So if we put all of this in the long-term perspective, where we take a look at the average global temperature from 1900 on the left all the way to 2026 on the right, we can see, of course, that long-term increasing climate change trend. However, there's also that important year-to-year variability. So each bar represents 1 year. So you can see that there's some variability from year to year, those ups and downs, but there's that clear, very long-term warming trend as we get closer and closer to 1.5 degrees above pre-industrial levels for the month of April in particular. And so another way we can also look at global temperatures is we can actually look at areas how they rank in terms of that long historical record dating all the way back since the 1800s. So the areas that I really want to highlight are in those dark red squares. Those are locations that observe their warmest April on record. And I really want to point out across the Pacific Ocean, stretching, if you look closely on the left-hand side, from Hawaii all the way to off the coast of Mexico. This has been a really persistent and high impact marine heat wave with record warm air and sea surface temperatures across this area, stretching across again quite a large area, even spreading along to the California coastline. And again, this has been a very persistent marine heat wave with large impacts to marine ecosystems in that area, as well as to coastal communities. So this is one area that we'll be monitoring, especially as we see those warmer ocean temperatures begin forming in the tropical Pacific in response to El Nino. And so the big question that a lot of people are asking, and we'll dive into this a bit more as the presentation goes on, is where will 2026 rank for global temperatures, especially as we see this El Nino forming, which is typically associated with warmer global temperatures? So one way we like to look at this graph is we like to compare where we are in 2026 relative to recent years. So far, we're pretty close to recent years for global temperature rank. January to April 2026 ranks as the fifth warmest for that period on record using NOAA global temperature data. But as we can see, they're very close to the other years. So it's increasingly likely that 2026 will rank within the top 5 warmest years on record. And it might even inch closer and closer to those higher rankings, again, as the El Nino that I'll keep saying over and over again starts to form. So here's a map now diving into the global perspective of those really warm ocean temperatures. So anywhere in red means that it was warmer than normal ocean temperatures. So as you can see, this is covering pretty much the entire map. So what I really want to draw your attention to is where are some of those really big hot spots. So that's the dark red colors. So areas such as across the northern Pacific, or that marine heat wave that you can see closer off to the coast of Mexico and Southern California, where there's really warm ocean temperatures. The box outline that you see here is that region where we look for El Nino. So this gives us clues to how the El Nino might be forming in that area. So if you look closely to the continent of Western South America, you can see some of the deeper reds forming in that particular region, giving it a clue that we can already see the conditions in that area transitioning from that La Nina we had observed in the last year and now warming and warming. But as you can see from this entire map, ocean temperatures are quite warm, especially in those off equatorial regions of both the northern and southern hemisphere. And so I want to always provide the long-term perspective of where we are. So if we look at all of the ocean temperatures globally averaged from 1900 on the left to where we are today on the right-hand side, we can see again that long-term warming trend. And again, 90% of that excess heat from greenhouse gases and the burning of fossil fuels, all of that goes into the ocean, contributing to this long-term climate trend. So we can see again, 2026 is ranked as the second warmest April on record for global sea surface temperatures. So what if we zoom in now to the United States, where we are looking, especially coming off of that record historic March that we observed across the West? So this map is now showing the temperature anomalies just over the lower 48, where the darker red colors are indicating parts of those regions, like in the Ohio Valley, across West Virginia. Some of those regions were more than 10 degrees above normal for April 2026. So it was particularly warm this month across the eastern half of the US. If we average all of the temperatures across the lower 48, April 2026 was the third warmest on record for average temperatures. It was especially warm for those nighttime, overnight temperatures that really are also part of that long-term warming trend. In fact, 8 states set new temperature records statewide during the month of April. So it was yet another remarkable month across the US for climate conditions. If we put that also into the long-term perspective, what you see here is that average temperature for April from 1900 to 2026. I've outlined here sort of that long-term trend line. So you can see the yellow line, that's the year-to-year April temperatures. So lots of variability, but overall that long-term warming trend, and we can see where we were in 2026 relative to this historical record. So one of our tools we have at Climate Central is to also take a look at how can we attribute how much human-caused climate change has affected some of those conditions. So this is a new map that shows the monthly state average for the number of days where climate change made those temperatures at least twice as more likely. So in this month, despite some of those records being broken across the eastern half of the United States, we also saw a big climate change contribution across parts of the Southwest, which have been really warm this year. So states like Arizona, Utah, Colorado, those states observed at least 10 days on average with climate change, making those temperatures at least twice as more likely. So we encourage you to check out the Climate Shift Index tool that we have here at Climate Central, where you can actually look day to day how climate change is making temperatures more or less likely over different regions all around the world. So in addition to that really, really warm temperatures we've been seeing across the US, it's also been really dry. So in fact, 2026 ranks as the second driest January to April on record for the contiguous United States. The maps here breaking down April conditions, and really this pattern has been quite consistent if we look at these maps for each month of the year, where we've been seeing really dry conditions across the Southeast, especially the panhandle of Florida, southern Georgia up into South Carolina. And we've seen the wet conditions, sort of the storm track has been really pushed over the Great Lakes. So one of the only regions that has actually observed above normal precipitation this year has been across Lake Michigan, Wisconsin, and those areas. And much of the rest of the country has been particularly dry. And so we can check in on the drought monitor. And this is where we see some really striking statistics where more than 70 some percent of the US in the lower 48 is abnormally dry or in a drought. In fact, 46 states are observing some region with at least moderate drought conditions. So this data actually came out today, the latest update from the Drought Monitor, where you can highlight the different severity of the drought. So you can really see again that region from South Carolina, southern Georgia, and the Florida Panhandle, really in that exceptional drought region. And more than 153 million people across the lower 48 are currently impacted by the drought, which is really stretching again across the whole country outside of that sort of Great Lakes region. Another metric we look at for monitoring drought conditions and helping to sort of provide the long-term perspective is something called the Palmer Drought Severity Index. And so what this means is it's sort of a measure of how unusually dry or wet conditions are, and it takes into account information like temperature, precipitation, and really the soil's ability to hold water. So thinking about whether the soils are really dry or wet, and it averages essentially all of that together to give you this metric. And what this is really striking for this particular month is this is taking a look at all April conditions for this index from on the left, 1895 to 2026 on the right. And you can see that current conditions, we are in an extreme drought according to this metric. It's the lowest ever recorded for the Palmer Drought Severity Index, even surpassing that Dust Bowl period in the 1930s. So we can see across the US, it is very dry and it has been very warm so far this year. So when we take a look at those average temperatures and break it down by region, this is showing those conditions for January to April 2026. So anywhere in the dark red means it's been record warm. So much of the west of those areas are observing record warm conditions so far this year. That includes the entire state of Arizona. And this year, as I said, it's been record warm, but we can also go back further in time and see that it's been a record warm of the last 12 months, the last 18 months, all the way back to the last 60 months. So we are truly in a historic period of time for temperatures across the contiguous United States where they are just record warm and impacting a lot of people. So what does it look like going forward into the future? A question is this likely to continue? And I can't give you a clear answer whether these record warm conditions, and we'll take a look for now just at the short term, and it shows very much more the same. So over sort of the next 2 weeks, much of the lower 48 is going to see a higher likelihood for warmer than normal conditions. That's that map there on the left-hand side. On the right-hand side, we can see much of the areas where there might be above normal precipitation is most likely across that central U.S. region, anywhere from southern Texas up through the Great Lakes. So this is very much a continuation of that same pattern we're seeing where, unfortunately, it does not look like much drought relief is coming, at least in the short term, across parts of the Southeast. So now the big question that everybody is talking to, especially today, and I'll mention why today is important, is El Nino. So today we got the latest update from the NOAA Climate Prediction Center on their outlook for how El Nino is likely to emerge. So I thought I'd quote from their diagnostic discussion that just came out this morning, and they note that El Nino is likely to emerge soon with an 82% likelihood for the next several months and continue through the Northern Hemisphere winter. So there's a 96% chance of an El Nino for the upcoming Northern Hemisphere winter. These are very high odds. So this is showing, clearly an El Nino is coming our way. So the next question is about sort of its intensity. But I wanted to show a visual of what does that look like for what the next few months. So this is an animation, and it's coming from seasonal climate models that they take the current conditions of things like the atmosphere, the ocean, and they project forward into the future, going out up to almost a year in advance. So what you're seeing here is how the sea surface temperature anomalies globally are forecast to change from some of these models all the way through December of this year. So as you can probably note, there's that big red and building blob there across the Central Pacific Ocean, right off the coast of South America, extending across the Pacific. That's the El Nino we're talking about. So an El Nino is characterized by warmer than normal sea surface temperatures for that particular region. But the reason El Nino gets so much attention is that this area of warmth across that part of the world has global impacts. So it can affect things like global precipitation in different regions. It affects the monsoons. It can affect where wetter or drier than normal conditions are. It can cause droughts in some regions. So El Nino is a really important indicator to give us clues about how climate extremes might progress throughout the rest of the year, in addition to its relationship with also global temperatures. And I'll show a visualization of that in a moment. So what about the intensity? So we can see very visually on that map this big red blob that's continuing to form through 2026. What does that mean in terms of intensities? So one of these new metrics that actually started recently from the NOAA Climate Prediction Center is giving you a likelihood of how strong different strengths for El Nino might be. So I want to orient yourself on this bit technical of a graphic. So at the bottom is showing 3-month periods for seasons. And I want you to focus on OND, so October, November, December, and all the way through DJF, December, January, February. And take a look at the bars here. And I've outlined some of the probabilities. So really the takeaway from this new forecast, again, hot off the press today, is that there's a 2 in 3 chance of a strong El Nino forming by early winter of the Northern Hemisphere later this year. These are really high odds. So yes, there is uncertainty in the exact strength of what this El Nino might be, but these odds are quite high, especially at this far out into the future. So again, every El Nino is different in terms of its impacts around the world. And stronger events don't necessarily mean there's going to be more impacts, but there's definitely a higher likelihood of that occurring. So this is really indicating that we are headed for potentially a very rare and unusual El Nino event this year. And so, again, like I mentioned earlier, one of the ways we take a look at those forecasts for El Nino is from these seasonal climate models. So each of these colored sets of lines are showing some of those different models, so that those complex acronyms you see there are just different models from climate institutions all around the world. And this is one of the metrics we use to look at the intensity of El Nino throughout different times of the year. So it's called the Relative Oceanic Nino Index, or RONI. And that's taking, again, looking at where anytime you're sort of above that dashed horizontal line that's red, that means you're in El Nino conditions. And so if you get higher and higher on those indices, that means a greater likelihood for a stronger El Nino event. So one takeaway here is that clearly all of the climate models that you see here that make predictions are indicating an El Nino event coming up later this year. However, you can see there's still a large spread in the intensity. So, if you compare the top of that thin colored line in green to the sort of bottom red thin colored lines, that's showing you there's still a large spread and still uncertainty in some of our forecast models for how intense this event might be. So we will be providing monthly updates on the likelihood of this El Nino developing with the next couple monthly climate briefs. We're also going to dive in later this summer to more clearly show some of the impacts you might expect region to region around the world this summer and next winter as this El Nino continues to form. And as I mentioned earlier, in addition to those regional climate impacts, it also has global climate impacts. So there's a tendency during El Nino years for it to contribute and boost global temperatures. So what the real takeaway here is that we know global temperatures are rising due to human-caused climate change. That's sort of that line you see here. That's the long-term trend. And what an El Nino can do is it can temporarily boost global temperatures even warmer. So if you notice, there's a lot of those red dots above that line there. Those are years that had an El Nino event during them. And you can see they're not always, but they're more often sort of boosting global temperatures. So it's very likely, given the strong El Nino event that is increasingly more probable that global temperatures will be boosted even warmer. And especially as we get later on in the year into 2027, they could be record breaking. So how record breaking? Well, this graphic now takes a look at those same forecast models. And on the right-hand side, it's giving you the forecast for global temperatures relative to pre-industrial levels. So the global temperature anomaly relative to 1850 to 1900 conditions. So that dashed solid black line showing you at that 1.5 degree threshold, that's very policy relevant, often discussed in the news. And so you can see then those yellow lines are showing individual forecasts from those models, and then that red line is showing you the model average. So what's the takeaway? The takeaway here is that global temperatures are forecast to warm in terms of how anomalous they are as the year progresses. And you might also notice that they're progressing quite warm, record-breaking conditions by the end of the year. In fact, some of those lines are approaching 2 degrees above pre-industrial levels for some of those forecast models, which would make those months the warmest month ever on record for global temperatures. So this is really a striking forecast currently from our climate models that make these seasonal predictions. And we'll be watching this very closely later on this year to see how anomalous global temperatures may end up getting. So the takeaway from this sort of overview from this month is that conditions are warm, particularly over the oceans. April ranked as the fourth warmest on record globally, and we continue to see a higher and higher likelihood for potentially strong and unusual rare El Nino to form later this year. Zooming in across the US, it's been really warm, historic warm, and dry, where nearly 62% of the lower 48 is currently in drought conditions. And one of the metrics that NOAA produces is something called the US Climate Extreme Index. What that does is it takes a look at things like extreme temperature, precipitation, and drought conditions. And if you take a look at that for the January to April period from 2026, that's at a record high level, indicating that the start of 2026 has been historic for extreme weather across the US. Looking out into the next 2 weeks, we can expect much of this same pattern to continue, where there's a higher likelihood for above normal temperatures continuing across much of the lower 48. So tune in. Our next monthly Climate Brief webinar will be June 16th. We will again provide the latest update, particularly on El Nino, also, how current drought conditions are developing. We're also really excited. We're going to have a special guest talking about the hurricane season outlook for 2026, diving into what the current hurricane outlook looks like for this year, as well as providing resources to better understand the connections between hurricanes and climate change. So all of that will be coming up next month, and we encourage you to tune in. So now I'm going to turn it over to our special guest this month, Dr. Ali Mazurek, who got her PhD at Colorado State University in atmospheric sciences and is now an engagement climatologist at the Colorado Climate Center in Fort Collins, Colorado, who will dive into a bigger update and more details on what's going on across the West in terms of that consistent snow drought, water drought, and temperatures going forward into the future. So I will turn it over to Ali.
Thank you, Zach. I will go ahead and share my screen here. And there we go. Hopefully everyone can see this okay. Let me know if you cannot. Yeah, so thanks for the kind introduction, Zach, and thank you to the Climate Central team for having me today. As Zach mentioned, I am a climatologist with the Colorado Climate Center. We're based at Colorado State University at the Department of Atmospheric Science. And kind of the main role of our office is to study Colorado's climate, but we also talk about the West in general in situations like this. So yeah, I'm going to kind of talk about the situation that we've been seeing out here over the last 6 months or so, and kind of talk about what those implications could mean for the summertime. So kind of just to start, what has been happening in the Western US. So it's been a record warm winter. This graph on the right, Zach showed a few of these similar graphics. This one is showing the statewide average temperature ranks for the November 2025 through April 2026 period. And anywhere that you see in those dark red colors there are states that saw their warmest November through April period on record. That's out of 131 years of data. So it's just been extremely warm. And also, as Zach mentioned, pretty much any time scale you look at, whether it's 3 months, 6 months, 12 months, a lot of these places have been seeing record warmth over that period. And not only have we seen record warmth, but we've also seen record low snowpack in a lot of locations. And as a result of that, our drought has been expanding significantly. We've also seen some early season wildfires in some locations. So, this past winter has just kind of been the winter that didn't happen. And, I work for the Colorado Climate Center. So, and Colorado is an important, we call it a headwater state. It's the source of a lot of the water that flows downstream in the Western United States. So I will kind of shout out Colorado on a few occasions here. But we like to make these, we call them quadrant charts in our office. And essentially just to guide you through this. So on the x-axis here, this is the accumulated precipitation. And then on the y-axis, that is average temperature. And these are all of the different years that we have in our data set. So just to highlight, 2026 is all the way up here on the upper left in this kind of warm, dry quadrant. So truly, and this is showing, I should mention, for the October through April period. A lot of times when we're looking at climate information, especially when it comes to water, we like to track over what is called a water year. And those water years run from October 1st through September 30th of the following year. So right now we're in water year 2026. That started on October 1st of last year. So over that period, this 6-month period from October through April, truly, I mean, just exceptional warmth and very, very dry as well. Some years have been drier in Colorado, but still has been quite dry this year. And just to kind of talk briefly about why snowpack matters in the West. So our snowpack is kind of everything when it comes to water in the Western United States. So this graphic here is just showing how much runoff we typically see from snowmelt, how much of that runoff can be attributed to snowmelt in the Western United States. So you can pick your region here, but as you can see, the majority of our water in the Western US comes from our snowpack. So, you know, when we have a poor snowpack year like we had this year, that definitely brings up reason for concern for the summertime as that snowpack melts off. We often anticipate there being less water than normal, which is certainly true this time of year. And you can see here that a number of these places, you know, it's not just the majority of water comes from snowpack, but, you know, 75, almost 80% in some location is derived from snowmelt. So very, very important source of our water in the Western US. And here's just another graphic to kind of emphasize this point. So a lot of people, you know, when you're seeing drought stories in the Western US, you see low levels on Lake Powell and Lake Mead. Once again, a lot of those reservoirs depend on snowmelt. So Lake Powell, about 71% of the water in there comes from snowmelt. Lake Mead, 69%. This graphic on the left, the dots are sized depending on how big the reservoir is. So, you know, Lake Powell, Lake Mead, Fort Peck in Montana all stand out as our biggest reservoirs. And those big reservoirs are also very dependent on snowpack, kind of being the key message here. So definitely, you know, this year has been bad and definitely brings up reason for concern. And I'll kind of dive into some of the specific numbers of the snowpack that we've been seeing lately. But just kind of one more emphasis point on why we are so concerned about the low water and low snow that we've been seeing this year is, you know, it's not just about filling our reservoirs that low snowpack has impacts on. The impacts can kind of be far-reaching as well. So with low snowpack, we often see temperatures get warmer over surfaces that would typically be covered in snow, that when they're not, we typically see those temperatures get warmer. And that's certainly something we saw in the Western United States this year, especially at kind of our middle elevations, like 7,000, 8,000 feet. We definitely saw places get warmer than they normally would if they had been covered in snow. Also heading into the summer with low snowpack, we've also seen early melt off as well with these very warm temperatures that we've been seeing. That increases wildfire potential because that allows more time for those soils and that vegetation in our mountain areas to kind of dry out and get crispy as this summer heat comes around and we get those really strong sun angles from our sun. So all of those being reason for concern for other impacts as well. Drought is obviously another big piece of this. When we don't have snowpack sitting on those soils tend to get thirstier. So yeah, lots of impacts from our low snowpack to be concerned about. And I know Zach kind of talked a little bit about the US Drought Monitor earlier, and I'll talk a little bit more about that here. So this is the drought monitor that was released just this morning, hot off the press. If we're looking at the Western United States, about 72% of the Western US is currently seeing some amount of drought. About 50% of the West is experiencing severe drought or worse conditions. In these kind of red and maroon colors, those are signifying extreme to exceptional drought. Once again, in a lot of the headwaters regions like Colorado. So again, certainly reason for concern as we think about our water and wildfire potential heading into the summer. And just to kind of show how things have changed. So this is showing how the drought monitor categorization has changed from February 17th through May 12th. And obviously our drought has gone back further than then, but things have kind of significantly deteriorated in the last 3-ish months. So anywhere that you see in yellow here are locations that have seen worsening drought conditions over that 3-month period. So the story throughout much of the Western US has been worsening drought conditions over this period. And I also want to emphasize that the reason that this product is very important and kind of necessary is a lot of the data that comes from the US Drought Monitor actually triggers a lot of our drought relief programs. So for farmers and things like that, they kind of depend on the US Drought Monitor for making those decisions and getting relief from the federal government in terms of that. So, a lot of people do pay attention to this product, and it's something that we've definitely been watching as well. So not the trends that you necessarily want to see when it comes to drought, certainly. And just to talk a little bit more about drought, I mentioned with low snowpack that we often get these drier, thirstier soils. And one way that we like to track that is through this metric called evaporative demand. So this graphic on the right is showing what we call the evaporative demand drought index. And anywhere in these dark red colors are kind of our highest category of that. And this is showing that for the 6-month period ending on May 9th. But pretty much, any period that you look at in the last several months shows kind of these dark maroon colors across large swaths of the Western United States. And essentially what that's telling us is that our soils and our vegetation, our crops are seeing very strong demand for water. So they're very stressed. They're drying out, that sort of thing. So so this is certainly something that we've been watching as in terms of how it feeds into our drought situation. And these numbers really scream that the drought situation is pretty bad in a lot of locations right now. Okay, so now just diving into snowpack a little bit more. So I mentioned that we like to track our water and a lot of our climate metrics in the Western United States in terms of a water year. So again, that runs from October 1st through September 30th of the following year. So this graphic here is, again, just focusing on Colorado. And it's basically showing our accumulated snowpack over the state from October 1st through September 30th of the following year. And all of these colored lines here are all signifying our historical snowpack. And we like to track our snowpack in terms of snow water equivalent. So that is how much water is in the snow, because once again, that's really what matters when we're talking about how much water is going to flow downstream into our rivers and our reservoirs, rather than snow depth, which is kind of a less useful metric. So with our snowpack here, you can kind of go to the minimum numbers here in our historical record in red, all the way up to the maximum in blue. And then this black line here is showing 2026. So right now, as of yesterday, Colorado's current snowpack is sitting at about 15% of the 1991 through 2020 year average. You can see the green line here is showing our average snowpack, and as you can tell, we've been running way behind all winter. But really what was made things go from bad to worse was what we saw back in March, when we saw very high temperatures, record shattering across much of the western United States, that really took a significant hit to our snowpack and caused rapid melt off. This is something we don't typically see until May in Colorado, and that's true, for other states, Utah, Wyoming, those locations. So this was very unusual. We did, get a few little boosts in April, but again, not enough to kind of change our overall situation in the state. And then this graphic here is just showing our automated snow measuring sites. So these take daily measurements of how much water is in our snow. And anywhere here that you see in those kind of dark navy blue colors are locations where 2026 marked their lowest snowpack on record. This is going back to April 1st because I think it's a little bit more useful than May. May gets a little wonky with things melting off and being dry. So I went back to kind of closer to when most of these locations are sort of expecting to see their peak snowpack. So around the time that we would expect peak snowpack, a lot of those places peaked at their record low in 2026 compared to their historical records. So as you can see, widespread across the West, not just true in Colorado. And then just one more snowpack graphic here. This is just showing our basin conditions. So this is showing the percent of average snowpack over that 30-year period, 1991 through 2020. And this is now looking at April 15th, so a little bit further in time. But you can see from the percentages here, every major basin in the western U.S. was running behind average this year. The best conditions were further north, towards the Missouri River Basin. Things were much worse as you headed further south, but even for them, still running below average. So it's safe to say that we can expect below average runoff throughout this year. And then just to kind of get into that runoff, so this graphic here is just showing runoff forecasts. This is from the official Colorado River Basin Forecast Center, released on May 1st. Anywhere that you see these magenta markers here are places that are expecting to see less than 30% of their average runoff across various stream gauge sites. In the western U.S., again, this is focusing on the Colorado River Basin, which if you're at all familiar with that, the Colorado River feeds 7 different states' water in the western U.S. as well as parts of Mexico. So, tracking the runoff there is extremely important. And just to kind of call out Lake Powell in particular here, the current forecast is currently calling for inflow to Lake Powell to be about 13% of average this summer, which again is a very dire number to see. And just to kind of wrap up in a couple slides here, so with this low snowpack, there's kind of far-reaching implications. One of them being tourism. I mentioned the concern for wildfires this summer. Wildfire smoke is extremely unhealthy to people. People don't enjoy being outside in that. Here's just a picture here from the Cameron Peak fire in 2020. This is not something that people like to be outside in. And we've already seen a lot of impacts as well. There's been some stories this year so far talking about the rafting industry along our riverways in Colorado, as well as other places, lots of people having to navigate below normal stream flow and kind of questioning how far into the season these places might be able to run their operations. This story here from the New York Times, this is where this photo came from, was, pretty dire. This is a photo from Aspen on their closing day. I definitely recommend checking that article out. Hopefully it's a gift article, but the photos in there were just truly shocking to say the least. So tourism is just one particular impact. And then another thing that we've already started to hear a bunch on is from farmers and agricultural producers. These are just a few narratives that I pulled from some of these. These are from what we call the COCOROS network, which is a citizen science rain gauge observing network that's nationwide. You basically just take a rainfall measurement once a day, I think in the link in the chat, you can check that out and join if you're interested in being an observer. But through the CoCoRaHS network, we also have these condition monitoring reports from our observers, and you can read some of the narratives here on your own. Lots of folks reporting just very dry conditions, poor crops. A lot of our observers are also farmers or ranchers, that sort of thing. So we're already seeing a bunch of impacts to our agriculture as well. Lots of concerns over how much water these folks are going to get in the summer to take care of their livestock and their crops. So just to wrap up here, what can we expect in the West this summer? Water restrictions, we're already seeing those in a lot of places. Increased potential for wildfires. Above normal temperatures are expected to continue, as Zach kind of mentioned. We expect impacts to agriculture. Farmers are already starting to make adjustments to what they're planning to grow this year. We can expect our drought conditions to persist and expand. I mentioned impacts to tourism. Those are expected to kind of continue into the summer as well. So kind of far-reaching impacts here in the West and even beyond. You know, a lot of our wildfire smoke, for instance, can carry pretty far away. So some other folks might be seeing impacts from that as well. And then last slide here, Zach talked a lot about El Nino, and he shared a great link to the Climate Central's website about what El Nino means in terms of impacts. So just want to highlight that, you know, this is something that we've been watching in the Western US specifically, because as you can see here, this graphic here is showing the kinds of conditions that El Nino tends to favor in the United States when it is active. So in the Western United States, we do tend to see wetter than normal conditions. Even, you know, this graphic doesn't show it super well, but a lot of those bleed into Colorado as well, which of course is important in terms of, once again, water and snowpack and that sort of thing. So if we do see a shift towards that this summer, definitely hoping that that could bring some drought relief, but, you know, with some caveats. The relationship is not perfect between El Nino and precipitation, but it does certainly inspire at least some optimism, I would say, to hopefully at least chip away at some of those deficits. Maybe not totally give us relief, but at least some amount of positivity. And that's all I have. I'll just leave this slide here. Feel free to reach out to me if you'd like. These are all links to our website if you're interested in Colorado specific data, and feel free to reach out if you have any other questions. And that's all I have. Thanks so much.